This video is on the normal distribution. A normal distribution is roughly symmetrical about a central value, and the curve is bell-shaped with the majority of measurements grouped around the central value, as you can see in this picture here. The location and shape of the curve is determined by parameters of the distribution, which are the mean and the standard deviation. If a random variable x has a normal distribution with a mean and a standard deviation, this is how we write it. So the symbol for the mean is this one here that I've circled in red, and the standard deviation, the one that I've circled in purple. Now notice in our notation for the normal distribution, it is the mean and the variance, which in normal distribution is our standard deviation squared. Now for any population that is normally distributed with a mean and standard deviation, approximately 68% of the population lie between one standard deviation away from the mean, so above and below, which on this diagram here is this shaded section here that I've shaded. 95% will lie between two standard deviations above and below the mean, which will also then include these ones. And 99.7% lie within three standard deviations, and it also includes these sections. And that's just in a different way there, so you can see. Now, first example, a sample of cans of peaches was taken from a warehouse, and the contents of each can was weighed. The sample mean was 486 grams with a standard deviation of 6 grams. State the proportion of cans that weigh between 480 and 486, or more than 492. So if we think about plotting this on a normal distribution curve, our mean is at 486 grams. So that's going to be halfway. Now our standard deviation is 6, so our next section across, above that would be 492, and then that same below is 480. Now for this first question, we are wanting the proportion of cans between 480 and 486. So we are wanting this section here. Now if you look at the diagram before, you see I have shaded this section here, which is 34.13%. So the proportion for part A would be 34.13%. Now part B wants more than 492, which will be everything above this line here. If we go back up to our diagram from before, you will see that it is going to be this plus this plus this, because our 492 is this point here. So we just add all those percentages together and we get an answer of 15.87. Next example. The chest measurements of 18-year-old male rugby players are normally distributed with a mean of 95 centimetres and standard deviation of 8 centimetres. From a group of 200 18-year-old male rugby players, how many would you expect to have a chest measurement between 87 and 111? With this one, we know our mean is 95, so the middle will be at 95, standard deviation of 8. So below that would be at 87. Next one above that would be at 103. Next would be 111. The next one below would be at 79. Now, how many would we expect to have a chest measurement between 87 and 111? So we are looking at these three sections. Look back at that diagram from before, and if we add those three percentages together, you would end up with a percentage of 81.85%. Then we want a group of 200, so all we have to do is multiply that percentage by 200, which is approximately 164 players would have a chest size between those two values. Part B, find the value of K such that approximately 16% of measurements are below K. Now if we go back up to our diagram, 16% below K, so if we looked at what we have here, 16% represents everything below this point here if you were to add those percentages together. So our K is going to be this part of our diagram, which is the 87. OK would equal 87. Now when we get to using technology, which generally you will have to do, on the TR Inspire, these are the steps for you that you can go through. And we're going to use these for these next few examples. So example 3, the variable x is normally distributed with a mean 40 and standard deviation of 10. Find, for part A, the probability between 37 and 48. So I'm going to go straight to the calculator to work this out, but what we will find is the answer should be 0.406. For B, we're going to have the probability of x is greater than 45, which should give us a value of 0.309. And for the last one, we put it in the calculator, we should be getting an answer of 0.081. I'm going to go straight to the calculator now and show how we get all those three values. This example on our calculators for the normal distribution, we need to go to Menu, once again Probability, Distributions. As we are going between two values, we want normal CDF. Our lower bound here is 37, our upper bound is 48, our mean was 40, and our standard deviation was 10. Just put all those values in, click OK, and there you see we get the answer we found, which was 0.406. For the second one, we still need to do a CDF, so it'll be Menu, Probability, Distributions, and a CDF. Our lower bound this time, we want x is greater than 45, so our lower bound will be 5, but our upper bound is going to be a big massive number, so the best thing is to put 9, click the double E button here next to the A, and then just do 3 more 9s. Our mean is 40 and the standard deviation is 10. Put that in and you see you get our answer. And then the same idea for the last one when x was less than 26. So Menu, Probability, Distributions, Normal CDF. This time our lower bound will be that negative 9E999, a very, very small number. Upper bound is 26. Our mean is still 40 and our standard deviation is still 10. And there you see you got our answer of 0.081. Example 4, the times taken by students to complete a puzzle are normally distributed with a mean 28.3 minutes and standard deviation of 3.6 minutes. Calculate the probability that a random selected student took at least 30 minutes to complete the puzzle. And then B, out of 10 randomly selected students, 5 or fewer of them took at least 30 minutes to complete the puzzle. So for part A, from this information is our mean is 28.3. Now our next value is the variance, so it's the standard deviation squared. And we want the probability that it took at least 30 minutes, so we want when x is greater than or equal to 30. If you put that in your calculator using the method I showed you before, you should get an answer of 0.318. Now B, out of 10 randomly selected students, 5 or fewer of them took at least 30 minutes to complete the puzzle. Now with this one, because we have trials, we have 10 randomly selected students, we have a number of trials, it is actually a binomial. So we have 10 students and 30 minutes, we want at least 30 minutes to complete. We've just worked out the probability of that in the last example, which is the 0.318. Then we can use our binomial functions on the calculator to work out the probability that it is less than or equal to 5. And using the binomial for that, we will get 0.938. If you're not sure how to do that in the calculator, go to my binomial video and I show you how to do it in there. Now, it is possible to convert any normal distribution to a standard normal distribution, and this can be done to help us work out sometimes what the mean or standard deviation or variance are. Now, we use this rule here, which is z equals x minus the mean divided by the standard deviation. This process is called standardization. So for this example, given that x, our normal distribution, has a mean of 10 and a variance of 2 squared, so standard deviation of 2, find the probability of x is less than 13. So we know we can just do this by doing it the other way in our calculator, but I just want to go through the standardization and you'll then see we get the same answer. So if we are going to standardize this, z will equal our x, which is 13, minus our mean divided by the standard deviation, which gives us 1.5. So that is telling us the probability of x being less than 13 is equal to the probability of z being less than 1.5. If you put the probability of z is less than 1.5 into the calculator, you will get an answer of 0.933. Now remember, for the z, we have our mean is equal to 0 and the standard deviation is equal to 1. So that's what you put into your calculator for those sections. Probability of x being greater than 9. Same idea, so we'll have 9 minus 10 over 2, which gives us negative 0.5. So our probability of x being greater than 9 is equal to the probability of z being greater than negative 0.5. Put that in your calculator with the z using the mean as 0, standard deviation as 1, and you will get 0.691. So you can always check these by doing it the normal way, so you can see that we do get the same answer. Then for C, we want the probability of x being between 9.1 and 10.3. So if we're doing standardization with this, you have to do it for each part. And for this side, you get 0.45, and then we also have to do it for the 10.3. And we'll get 0.15. So this means for our z, it would then be between negative 0.45 and z and 1.5. And then put that into your calculator and you will get 0.233. So obviously you can see for normal calculations, there's no reason to standardize it, but when you want to find your mean or standard deviation, then you need to. Now, the inverse normal distribution on your calculators can be used when you are given the percentage area under the curve and we're asked to find the value corresponding to it. And once again, there's the information about the calculator, and it's always good to draw a sketch because we will have to use the area to the left of the value we're trying to find. So in this example, given that our normal distribution has a mean of 0 and a variance of 1, use your graphics calculator to find these. So this first one, if we were to draw a quick sketch, we know the probability is 0.877, so it's going to be somewhere above the mean because the mean is 0.5. We're wanting z being less than this value, so we are wanting this part, which is fine. So when it's shaded to that side, we can just use the inverse in the calculator to work that out. Follow those steps with the calculator and you should get an answer that A equals 1.16. For B, now we're wanting when the probability is 0.2, so our z is greater than A. So 0.2, and it's greater than, means it's going to be at this side again, but because we're wanting greater, we are wanting above that line, so that's where the 0.2 is. Now, as I said before, on our calculators, we can't do that. We have to have the shaded area below, which means we actually are wanting to find when z is less than A equal to 0.8. Now use that in your calculator. A is equal to 0.842. C, the probability, it is between negative A and A, and that is 0.42. So on our nice beautiful probability distribution, we are looking between two values, so we're looking for this shaded area here. This would be negative A, and that part there would be A. Now remember, as we've got negative A and A, it means it is symmetrical, so these bits either side will also be equal, the bits that are shaded in purple. Now if this middle section here in red is 0.42, means the total of the purple areas would be 1 minus 0.42, which is 0.58. So half of those, so just one of those sides, will be 0.29. So say for example, this section here will be 0.29, and this section there will be 0.29. So from there then, we can then work out what our A values are. So we can work out what negative A is, because we can do that z is less than negative a, and that would equal 0.29. That will equal negative 0.553, so therefore a would equal 0.553. Example 2, we've been given that the normal distribution has a mean of 15 and a variance of 3 squared. Determine x where p of x is less than x equals 0.75. Let's draw a diagram. We're wanting when x is less than x, and that's 0.5, so which means it will be above the mean. This is where 0.5 would be. That's where 0.75 will be, because it's a less than, it's everything below the line. And then this will be x. Then we just need to work that out. And then just put that into your calculator and you will get a value for x of 17.0. With that, you could have standardized it and done the same thing, but there is no need to, so you can just use the inverse normal function. Example, 3 cartons of juice are such that their volumes are normally distributed with a mean of 150 ml and a standard deviation of 5 ml. 5% of cartons are rejected for containing too little juice. Find the minimum volume to the nearest ml that a carton must contain if it is to be accepted. So with this question, let's work out the information we've been given. So for our volume, the normal distribution, our mean is 150 and our standard deviation is 5, so the variance is 5 squared. 5% of cartons are rejected for containing too little juice, and we're wanting to find what that value is. So we're wanting to find when the volume is less than m and when that equals 0.05. What value gives us 5% error? So on a sketch, we are wanting to find this shaded section here, which is just 5%. Put that into your calculator, into the inverse normal, and you'll find that the minimum volume is 142 to the nearest milliliter. Sometimes we may have to find the mean or standard deviation. So sacks of potatoes with a mean weight of 5 kilos are packed by an automatic loader. In a test, it was found that 10% of bags were over 5.2 kilos. Find the standard deviation. So this is when we have to use standardization, because we can't do it in a calculator or anything like that. So for this, our mass, we're going to use m, and our normal distribution, we have a mean of 5, we know that, but we don't know what our standard deviation is. We also know that the mass greater than 5.2 is equal to 10%, so 0.1 is 10% greater than 5.2. So on a sketch, because it's greater than, it would be this, and this would be our 10% at 5.2, and this is 10%. Now, so this is when we need to standardize. So we know from here that z, if we're working out a z scored, would be 5.2, because that's the value we're looking at being greater than, minus our mean, which is 5, over the standard deviation, which equals 0.2 over the standard deviation. Now with this, with our z, remember we know for a z, the mean is 0 and the standard deviation is then 1. And so we're wanting, now the probability of where z is greater than 0.2 on the standard deviation equals 0.1. And when we're greater than, we don't want the greater than, so we actually want when z is less than 0.2 over the standard deviation, and then that would equal 0.9. And by using this information here with our mean and standard deviation be 0, because we standardize it, we can then do the inverse normal. And if we do that, we find that the 0.2 over the standard deviation equals 1.28155, because that's the solution we get from the inverse normal. And then we can work out the standard deviation with rearranging, which is 0.15. 0.056. The last example, sometimes we have to find the mean and the standard deviation. So in this situation, we've got a manufacturer who does not know the mean and standard deviation of the diameters of ball bearings she's producing. A system rejects all ball bearings larger than 2.4 and those under 1.8 centimetres in diameter. 8% are rejected for being too small, 5.5% as too big. Find the mean and standard deviation. So with what we've been given here, we are trying to find D as the diameters, the normal distribution, and we want to know what is the mean and the standard deviation. We also know that when the diameters are smaller than 1.8, the probability is 0.08, and when the diameters are bigger than 2.4, the probability is 0.055, or 5.5%. This is once again where we need to standardize. So for this one here, it will be Z1 equals 1.8 minus the mean over the standard deviation. And then this side, Z2, would be 2.4 minus the mean over the standard deviation. For this part here, then the probability of Z being less than this is going to be equal to 0.08. Then with this one, because it's a greater than, we need to switch it to the other side. So it would be 2.4 minus U over standard deviation. And then we do 1 minus our probability here, which will be 0.945. Because remember, when it's greater than, we need to switch it to a less than. From there, we can do the inverse normal for each of these. And we find out that 1.8 minus the mean over the standard deviation will equal negative 1.40507. And then for this side, the 2.4 minus the mean over the standard deviation equals 1.59819. Once we've got that, we have two equations, two unknown variables, so we will solve simultaneously. However you like to do that, just use your calculator is what I would recommend. And you do that and you find that the mean is 2.08 and the standard deviation is 0.200. So on our calculators, just to show how to solve simultaneously if you're not sure, in menu algebra we have solve system of linear equations. We have two equations. Leave our values of the x and y. We'll say that x is the mean and the y is the standard deviation. Put in our two equations. Now you see when we solve that, we got an error argument. Sometimes it doesn't like the fractions. So what we can do here is we'll just multiply the y to both sides in each of them and get rid of the divide by y here. And if you do that, you'll find it will work. So sometimes with simultaneous solver, it doesn't like the division. You just multiply the denominator to the other side and it works perfectly. And that is normal distribution.